And I would like to let Catherine introduce herself and talk a bit about her work, and then she will start on her presentation today. Thank you.
So yes, I'm currently working at INRAE in the research center in Toulouse. And I mainly work on pigs, actually. Sheep is a long story, as well as rabbit and duck. My main topics is on meat quality and trait of interest for selection scheme in pigs. And in the PigWeb project, I am leader of the work package 3, which is about fair data in practice. And we try to think how to move our community towards open data and open science. So I will give our views on this topic. And because we have provided fair data guidelines that regroup a lot of concepts about fair data, data sharing, data publication, I will go through it to explain how we did our work. I will share my presentation now. Just a few words on PigWeb. So PigWeb is, for those who don't know, PigWeb is a research project on infrastructure. That means that it's a kind of project that the aim is to open our research infrastructure on pigs. And in part of this kind of project, there are several activities related to networking, and our fair data in practice is a networking activity. Today, I will talk about several things about data, metadata, and these fair data guidelines we worked on. And I will begin by some preliminary remarks on our pig research community, because in fact, the first thing we wanted to do during our in the PigWeb project was to have a kind of data landscape and data management practices in our pig research community, and to have a thought on this. We provided 2 surveys, one for institutions involved in the PigWeb project, and the other one on pig researchers. And you have the numbers of respondents for both surveys. The second survey was built on the state of open data, which is provided for all the communities who want to have a state on open data. It's very generic, and the idea was to be able to compare our community to other communities based on the same questions. So just a few things about this landscape. First, about the institutions, you can see that the respondent provided information on the fact that there are official policies on open data related to fair principles, both at the national level or for funders. But if you see at the middle of the figure, there are not really policy on metadata and how to collect data in a fair way. So this part means that we have to really have a better overview of this kind of things. The last question was about training, and you see that there are not in all the institutions, there are not training on fair data. But some have quite important training activities to go for open data and open science. About the pig research community, in general, the people are kind kind of prepared to share, but they don't want to share everything. I mean that they are prepared to share their articles. They can also share their data, but when you look at other things around the data, like programs or other information, they are more reluctant to do it. In general, people are not completely aware of all the FAIR principles. They have heard about it, but they don't know everything about it. But in general, they need more information. And about data, open data policy, when we are, so at the institutional level, you have some institutions that provide open data policy, but when you ask the researchers, they are not always aware of what is available. And about improving their knowledge, when you ask them how it's possible to help them to go to open data and to follow FAIR principles, you can see that it's very or everything is possible, but they are not really focused on one way to have help. And in fact, one of the positive answer is about colleagues and supervisors. So it means that people are await from their community, I would say, to help them to have a better open data policy. One of the concerns, because when you open your data, one of the ideas is that it has to be reused. And the main concerns is about the misuse of data. So if you share the data, maybe they will be reused in a wrong way, or you won't have credit for your data and for your work providing data. And the one concern also is about organizing the data, because if you want to share, you need to work on how to provide your data. And it's really related to some lack of time, because if you prepare your data for yourself, it's not always the same to prepare data for other people. And after you have a list of other concerns, but they are not the most important. If you want to look at all the results of these surveys, they are available on a GitHub. I put the website here. You have both the results of the survey and the program that has been done to analyze the data. You won't have the institutional response because they are more personal, and it was not possible to share them this way. So with all these questions for our PigWeb community, we worked on that, and we made some different webinars to talk about several aspects of FAIR data. And all this material has been further used to build the guidelines. So it was one of the deliverables of the PigWeb project. So the guidelines it's both a report, and it's also accessible on the GitHub as mentioned on the slide. So it's really the idea is that all people interested in these guidelines can access to it, and because it's a wiki format, comments can be made, and the idea was to improve the guidelines over the time. So I mentioned all the authors of the guidelines: Rob Lockers, Hendrik Bogart, Catherine Hurtaud, Nina Melzer, and myself. And we had 2 other contributors who worked on it, Claudia Casper and Sarah Fisher. So I have to thank them for providing all this great information for us. Just a remark on open science, because open data is only a part of open science. The idea of the open science is now promoted by several international organizations and also by European community. The idea is to have a free and unrestricted access to knowledge produced by researchers. It should help to increase rigor, accountability, and reproducibility of science, and also a kind of change how we make research and to get out our laboratories. I won't talk about all the aspects of open science because here we mainly focused on open data. So you see that open data is a small part of open science. So what is open data? Data that can be accessed and reused by anyone without technical or legal restrictions. It doesn't mean that they are always freely available. You can put some restriction for access, but the idea is that it should be as open as possible. Sometimes we know that all data are not possible to be shared because it's personal data and there are things, or you don't own all the data. So what has been established is that to open data, you have to follow FAIR principles, which means findable, accessible, interoperable, and reusable. So there are quite a lot of literature on FAIR principles. They are not always, it's not always possible to follow them as deep as possible, but in fact, the idea is to begin and to go on with it. So I put some definition on these 4 principles, but you can find quite a lot of information on it in other websites. But really, it's really easy to find now. And because Europe has done a lot on FAIR data and FAIR principles. So I want to talk about data and metadata because there are 2 notions that can be a little tricky. So that metadata in general is presented that data on data or information on data or anything that can complement data. The problem is that metadata for people can be data for other people. So what you have to understand is the interest of this metadata. It's a way to find the data or following the FAIR principles. If you don't document or you put enough information in your data, it will be very difficult to reuse them in the right way. So providing metadata can improve the quality of your data. So it can be, there are several representations, so it can be a map to find data, but it's just a way to show it. Another way to represent it is data is to provide good metadata means to provide a lot of information on your data, and it can be a large amount of information, and sometimes metadata are more important than data itself. So you see with this kind of thing that metadata needs quite a lot of work to be provided in the right way. So how, what do we focus on metadata? Because they are very useful. Yeah, I took a representation of the interest of metadata, because metadata are a way to link data set, papers, and any kind of information that can be useful for using the data. They are also provide a way to ensure the interoperability of your data or your data sets, because they can be readable by machine. And if it's also a way to access or to better find the data that you want to find, or you can be interested in. Because if a data set is has not enough information, even if it's on a repository or available somewhere, it will be very difficult for you to know that this data can be of interest. And providing all this metadata can also allow to integrate different format or kind of data or data set or paper. And if it's provided in the right way, it really helps for data mining and to be more exhaustive when you make a systematic review, or if you want to do meta-analysis on data of interest, or to find new thing and new interpretation of all data. So really, it's really useful. But when you say that, we still don't know what kind of metadata you need to provide. So just to be clear, data must be really clear in terms of definition. So what measure you provide of units. Sometimes you have a measure, but the unit is not provided. So it's difficult to combine different data sets if you don't have the same unit, or even if you know the measurement. What kind of coding or classification? About coding, for example, the one is date, which has really different formats in the datasets. So sometimes combining date is difficult, and also the provenance of the data and how it has been processed. Just an example: if your information on data is not clear enough, there can be doubt or room for interpretation. And in this case, there's really a risk of overlooking data, and the reuse of data can be done in a different or even a wrong way. So we provided an example in the guidelines about pig pen. So for us, it's very clear what a pig pen is. It's a pen in which you put your pigs, but in other community, it doesn't have the same meaning. So you have to be really to provide, even for you, it's really clear. It won't be clear for another people or people from another community. So it's really important to provide clear definitions, and there are ways to do it, and I will give you some insight for that. Another way to provide good information is to work with standards and standardization. In our community, we know that there are no specific or even comprehensive standards for pig research and livestock in general when you talk about phenotypes. But there are some initiatives related to providing standards that can help to have clear data and clear metadata. So for data, you can provide a standard operating procedure, or at least the way you measure your phenotypes in a clear document. And if you add this or you link this procedure to your data, it will give relevant information on your data set. We promote also the use of ontologies to link data to definition of traits and environments. And for metadata, I think one of our community was work a lot on it is the genetic people working on genetics, because it's really when you put sequences or genotypes available, you really need to have standard procedures to provide your information, and you have repositories for that are very helpful for metadata. For phenotypes, trait measurements, we don't have this kind of initiatives, and we have to use other metadata standards which are not completely focused on our way we do things. I mentioned ontologies, but why is it important? Because you need to describe the set of phenotypic character or traits of phenotypes of interest in a homogeneous and, if possible, unambiguous way. And to do that, because if you provide your own definition of your trait, it's interesting, but it can be a little bit different than another researcher. So if you have a trait and you have the same definition of the trait, it's really helpful for combining data sets. And ontology is, as defined here, is really a formal and explicit description of concept that address a defined field of organized information. And the added value is that it makes concepts readable for machines by describing both the concept, which is mentioned as classes, and their relationship with other concept. Just an illustration on what I'm talking about. It's available from the animal trait ontology for livestock, which is ATOL developed by INRAE. So you see in the scheme that a trait is identified by first an ID, and the idea is it will be for this trait given as an example, ATOL 0000844. And if you have the link to this idea, you have a link to the name of the trait, but also a definition. And you can also, it's also linked to synonyms, for example, trait relative, and to possible method of measurement. So you can add a lot of information, and you have access to this information through a single idea. And how you can use this ontology to annotate your data. In fact, you take your name of trait. So here an example on behaviors, also taken from the guidelines. And you, for one trait, you put the ID referred to in the ontology. And if you have the link to this ID, you have all the information possible related to this trait. And it will be common for all people putting the same link in their dataset. Just to, because I mentioned ATOL, so the triplet ATOL, EOL, and AOL are ontologies developed for livestock by INRAE. So one is related to animal trade. One is related to environment in which animals are raised. And the last one is for animal health trade. But it's not complete or exhaustive ontology for all possible measurement we can have on our animals. There are also other ontologies of interest. One is GBI for chemical entities. It's really large. It's a really large one. It has hundreds of thousands of classes, so it's really large. But in this ontology, you can find a lot of metabolites of interest for biology. And the two other ontologies are also interesting. One is for vertebrate traits, so it's very generic for all vertebrates. You will find mice and other kind of animals. And the last one is about product, which can be also of interest for our communities. So things on meat or things like that. If you don't know what ontology use, there is a search engine, which is an ontology lookup service, and it references at the current time 255 different ontologies. So they are related to every kind of field, but in this kind of service, you can, if you want to search for an ID or an ontology term referring to your measurement, it's really easy to find it. About metadata standard, when you put, for example, a data set on a repository, like Zenodo, for example, if you want to provide metadata, it will be the double core standard, which is quite generic, in fact. But it has limited interest because it provides metadata really on the data set and about the author, the contributors, the dates, the versions, the rights, and so on. But it's not very useful to really describe your each measurement and each kind of data you have put in your data set. So in the PigWeb, FBN has worked on another standard, which is access to biological collections data, ABCD. It's used on related field, for example, ecology, but at so it's more flexible because you can really have a full description of your data, of your data set. But it's not very convenient to fill all the items. I show you a representation, which is a XML file. So we still need to work on the interfaces to give more to facilitate the access to this kind of metadata standard. What is interesting is that the standard can be completed, and we can provide new items of interest for our community. So I would say it's a work in progress, and it will be accessible when it will be more advanced. The last topic on data we talked about in our guidelines is about curation, because it's not always easy to know what kind of data you have to share. Because, for example, it's not always possible to share raw data. For example, people working on video, for example, there is no real way to share our video for people working on behavior, for example. So what is shared is the interpretation of the video with measurements of behavior from etograms, for example, but you won't be able to find video directly accessible on repositories. Two things, because the main thing is that it's a huge amount of information, and it's really difficult to provide the information you need on this video. People are not prepared, in fact, to share a video, for example, and there are other kind of data we have no mean to share at the moment. It's not that it won't be possible in the future, but we don't know how to do it currently. So you have, when you want to improve the quality of your data, you need to think about what you have done from raw data to shared data. So about data preparation, on structuring, how you put your data set, formatting, what kind of format you use, checking, of course, because when you provide data, you are the expert on your data, and you know if some data are not correct, and it's better, in fact, sometimes to correct the data before sharing and not to provide mistaken data. And so you have to, and for this, you can do it in different way. Either you share raw data and all the programs you use to cure your data, or you provide corrected data. At that point, there is no, we don't provide, I would say, it's not mandatory what you share. In fact, you choose what you share, but you have to be aware that you need to share the best quality, because otherwise it can be used still used in a wrong way, or not corrected the right way. The last thing I want to mention is about sharing or publishing. So it's more, for us, it's more or less the same thing. If you want to share, the idea is not to mail your data to someone else. So if you want to share on the large community, the better way is to publish them, to put them in a repository, and in this way you are sure that they will be available, they will be documented, and they will be correctly identified to facilitate the citation. It's not always synonym. You can put your data in a repository, but when you say publish, generally you need to be sure that it has been done the right way. So we promote that someone else look at your shared data to be sure that it's correctly done, but it's not always possible. So there are different strategies, in fact, for data sharing. The first one is to integrate data in an article, but this is possible only if the amount of data is limited, because when it's within an article, it can be more difficult to find or to use, and you have to make reformatting generally before using the data. Another way, if you publish your data with an article, is to provide the data as a supplementary data. So it's easier to find, because it's very difficult. It's very easy to access an article. There are really references in a lot of web services. So you ensure that your data are visible, but sometimes you don't have the right, you are not constrained by the format, and sometimes because of publisher limitation, it's not possible to share a large amount of data. And in this case, it's often that researchers, because it's related to an article, the information is supposed to be in the article, but in fact sometimes it's not enough, and it might be better to share it another way. So the way to do it is to use a repository, and we have made a list of possible repositories, and the best way to do it is to use repositories known or recognized by your scientific community. If you have a repository like repositories dedicated to sequences, for example, it's really better to put your data in this kind of repository, because they are made for that. If you don't have a dedicated repository, you can use generic repositories, and it's not a problem. Sometimes you have a little or no site limit, it will depend. And generally, this kind of repositories provide you direct data citation, and it's really interesting if you want to have your data reused. You have also a framework for metadata, but it's more or less rich. It's more or less easy to fill, and if it's too generic, sometimes dissemination towards your community is not always possible. You can combine, of course, an article or data paper, and you relate your data to shared in a repository. It's not provided as supplementary data, but they are linked to your article. And in a way, it's really a best way to do it, because you have a text that documents your data set and your experiments, and you have all the information on the data. If you don't have, or if you are not you have, for example, you have larger amount of data that are used in an article, you can also provide a data paper. There are not now publishers that accept data papers, or even if they are dedicated. Some are dedicated to data papers, and this kind of publishing is really interesting because it really increases your visibility. It has the advantage of peer reviewing, so you have an advice on your data, on your procedures, and it's also a better credit to authors, because it's related to an article, and it's referenced in the web services. In any case, it's better to have the choice of your repository, but you have to take into account the time for writing and sometimes the cost of publication. We really, what we promote is really to put the data in a repository, and either you provide all your information in the repository, because it's always possible to add additional files, or to relate it to data papers or an article if you have time to do it properly. For data repositories, why do we promote that? Because in fact, it's really they follow FAIR principles, so it's really easier to find the data, to access the data, because they receive a persistent identifier, generally IOD, and data can be searched and found and retrieved with search engine in the provided by the repositories. Here is an example. It's from Zenodo. So you can see that you have this identifier. You have keywords that will be searched for, used for by search engines, and you have also a license. So about the license, just a clarification. There are several kind of license. Here is a list for Creative Commons, which is quite popular, I would say. You don't give the same rights depending on the license. The repositories can use different kind of license. For example, here in France, we have a repository which is research DataGouv. They do not. It does not provide Creative Commons, but EthaLab, which will have similarities between the different kind of licenses. Just to go through different rights, if you put your data in public domain, you have no more rights reserved. So it means that your data are completely free. Anyone can do anything with it. So it's better to have at least the CC BY, because you have when people use your data, they have to be sure that the author or the creator of the data is cited. And then you have a different restriction. SA is for share alike. That means people can't reshare your data in a different way. And when you have NC, it means that your data cannot be used for commercial purposes. And the last ND, this one is not really recommended for us because it's non-derivatives. It means that you can't do anything different from your data, which is not. If you want to share your data, at least you want them to be reused and combined with other data set and things like that. So I'm not sure that any people in research use the NT. I've never seen it, but maybe it's not recommended at least. Because there are several repositories, we also provide advice for choosing a repository. If you have a disciplinary repository, really, you should use it because it's done for that. So, and it will be recognized in your community. If you have an institutional data repository, it can be easier because you have potentially you have training or information by your institution on this repository, and you can also have way to improve it. So it can be interesting, but not all institutions have their own data repository. In any case, you can use generalist or multidisciplinary data repositories, and some are promoted by different institutions or even by Europe, European community like Zenodo or Dryad, or Fieldshare even for data. And if you have no idea, you can still look at, you can search in a global registry, which is freedata.org, and you can find quite different repositories for your data. If you have sensitive data, you have to think of different ways to share them, which are called safe havens. And I think they are mainly institutional, but you have to be careful on that point, just to be sure what kind of data you share. At least a data, when you share your data on a repository, you have to be sure that the license is provided by the repository. Your data receives a DOI or PID or any individual identifier. And also, if it's possible to provide restricted access, or because, for example, you can share your data, but you want an embargo for a certain amount of time. For example, before your article is accepted, or so you can have a time limitation access, or you want to know which one access your data, and you can you also, if you want a registry of access, you have also to choose your repository with that constraint. We provided some tip for impact for sharing data. So be sure that you have a DOI, because it's really a very simple way to provide access to your data. It doesn't change, it's unique, it's citable. So it's really important to have this kind of identifier. Be aware of this licensing, because depending on your license, you can limit or not the access to your data. To be cited, if you want your work recognized, you have to give a way to be cited, and also to take time to provide good documentation and good metadata. Doesn't always clear what good is, but at least you have to do that. And also to provide context, anything that can be related to your data should be used. We mentioned other outputs. If you have access to SOP on another website, use the link. You can also link the data to yourself by ORCID or any identifier you have. The more link you provide with your data, the easier they will be found. And the recommendation is that when you publish an article on a data paper, you go from the data will be available. The data are available, and you can find them here. In the guidelines, we mention also how to provide a data management plan, which is very important. So I will not mention that here, but you have to be aware that it's really important to provide a data management plan and to anticipate all the aspects of FAIR principles in your data management plan, and to think. And if you think about all I've been through, metadata, repositories, publishing, and so on, it will be enriched it will enrich your data management. So do not hesitate to go to these guidelines and to provide comments if you have. And I have to thank again all the authors of these guidelines. So if you have questions, we still have a little time.
Thank you, Catherine. If you are shy with your questions, you can always write it in the chat. I would read it out loud. Any questions? So there's a question in the chat. How can we ensure equitable access to research data collected from animal farms while maintaining the ethical treatment of animals and protecting the privacy of breeders and farmers?
You have you can anonymize your data. It's the best way to do it, but that means sometimes you don't. You're right. You don't. It's a tricky question because if you want to be fully informative, you should say in which farm your animals have been raised. But if it's a private farm, you can't do it. It's not possible. So you don't do it. You have no way to do it. Or you have the authorization of the farmer, but it's better not to provide personal information. So you can either you can give a region, enlarge information. So you can put the country, at least it's informative, if not completely information, or a region. But in any way, you don't have the possibility to give the farm information. If you collect data on several farms, you just put a number or an anonymous identifier just to put that from different provenance. But it's very when you have personal data, really your first intention is not to share them.
Thank you, Catherine, and thank you, Eba, for the question. Any other question in the room? Maybe, Catherine, what would you consider like other challenges for livestock researchers to implement the FAIR data guidelines? Did you see anything aside from, I think the question from Eba is one of them, I suppose, with farmers and breeders and ethical use of data, but is there any other challenges regarding that?
You have to first you have to understand that PigWeb is a project, is a research infrastructure project. So the guidelines were more or less viewed for pig researchers, but experimental pig researchers in experimental farms. So in this case, you can provide information because it's not it's your institution. It's an institutional information, so it's not private. It does not be written for sharing private data, which is a little bit different. The challenge at the moment is to be clear on the information we need to document our data. We're still working on that because we have to balance what is necessary and the time you need to provide the necessary information. And the more you provide, the more time you need to dedicate to that. Thus, if you do it once, because normally it's not that you repeat the same experiments each time, but there is common measurements and common thing from one experiment to the other. So if you dedicate enough time the first time for one experiment, you will reuse a lot of information you provided these first times, and it will be easier and easier for the next experiments.
Thank you. Yeah, it's really interesting. And I think in the group, like right now, we have a lot of young and junior scientists. So what would be your tips to them if they want to start working in this type of project where there's the research infrastructure, but also the use of fair data principles, and what should they do to be able to work in this type of research?
They should check a list of useful information. So every kind of information they have on their data, they should write it and put it, even if it's not in a standard or whatever, even if it's a text, it's not a problem. At least the information is there and it can be provided with data. If they are in a community with a structured repository, they have to use them and they have to ask their colleagues how to use it. And they have to think that if they follow FAIR principles, it will be also useful for them. Because it's not only useful for the others. If you follow FAIR principles, it helps you even to reuse your own data. And the last advice is that it doesn't matter how deep you go, just begin. Even if it's not everything, it doesn't matter. At least begin to share. People will react with comment and it will be better than the next time.
Yeah, I think that's an excellent point to finish right on time, I think. Thank you very much, Catherine, for your time and for your presentation. It was very insightful. And I think if people from the audience have any questions, they can always send us an email through the social media. And also you can reach us through LinkedIn and follow the junior community. And we will always be available to answer questions or to forward your questions to anyone from PigWeb or HoloRuminant. I would also like to thank you, the audience that took time to be with us today. And soon you will get more information on the next webinars. Catherine, I don't know if you want to say un mot de fin, like we say.
Go to read the guidelines and give your advice or your comments. We will be very happy.
Thank you very much. Thank you, Diego.
Thank you.
Thank you. Bye-bye.